In this video, we are going to be creating classes that would hold our business logic, and we'll be interacting with the repository interfaces we created in the last video. The naming convention for this is called service. So let's create a package called service. Now we want to create our services in a loosely coupled way, meaning it should be easily extendable and be easily testable as well when we're writing unit test cases. This is also called test-driven development. For this, we'll create an interface of an employee and a class that implements that interface. So let's create an employee interface class. And let's also create a class that will implement this interface. And let's say this class will actually implement the employee service interface. All right. To explain more in detail why we need an interface of employee is because when we create an interface, we can easily mock the implementation of actual service and test it out when we're writing unit test cases. And also one of the biggest key points to interface is that we can easily plug in any services. So one of the best examples for this is a list interface. So for example, we have this list interface, and this is actually implemented by two classes, array list and linked list. So both of these classes have their own implementation. So list, if you go to the list interface actually, so if you go to the list interface, it has all of these methods: size, empty, contains, add. If you go to add, it has an add method as well. And if you go to linked list, you can see it implements the list interface. So it has its own implementation of add. And same thing for array list, is going to have its own implementation of add method. So this is one of the biggest benefits of having interfaces, where we can easily achieve abstraction and polymorphism, where our object can take many forms. So let's implement the employee interface. So we're going to have a couple of methods that we want to implement. So the first one is going to be get all employees. The next method we want to implement is be able to get employee by ID. We want to be able to add an employee, so be able to post employee. We want to be able to also update the employee information. And lastly, we want to be able to delete an employee as well. All right, so let's implement this interface. So now you see we're getting this error. So we need, if I hover this, it's going to say we have to implement all of these methods. So let's start implementing it. And actually, let me tag this with the service annotation. So this is going to tell Spring that this is a service class. Our employee service implementation will contain the business logic, and where we're going to be interacting with the repository interface we created for employee. So let's import that. So for that, we're actually going to use something called Autowiring. And we are wiring up the employee repository. So basically what Autowire is an annotation for dependency injection, which is a term in programming. It pretty much injects the implementation of the repository into our service. And Autowire will automatically initialize with the Spring Bean and find the application context for us automatically. And in this case, it's going to be the employee repository implementation. Okay, so let's start implementing these methods. So the first one is get all employees. This is pretty simple. We're just going to call up the find all method. And this is pretty much returning all the employees that's stored inside the employee table. The next one is get employee by ID. This is pretty simple as well. So we have find by ID. And here we're passing the employee ID. And if the employee ID is not found, let's say, we have employee ID that's stored at ID number 1. And someone passes in employee, let's say at ID number 3, but that doesn't exist. So we should throw an exception for that. So we're going to do or else throw a new exception. So we're going to say no such element found. All right, so next is add employee. So here we're saving up the employee information. This is easy as well. We just call up the save method, and this will save the employee information to the database. So our other one is employee update. So for this, we need to first see if we first need to fetch the employee information. So for this one, we want to first get the employee by ID and see if it actually exists. Actually, let's rename this employee details. So over here, pretty much a person can update the employee information such as their first name, last name, or salary. So we're gonna write the implementation for that here. So here I'm checking, you know what, get the first name. So for example, if someone passes in first name, if he doesn't pass in the first name, or if he passes in the first name, we need to check that. So here I'm checking pretty much that information. And same thing, we're gonna do it for the other ones as well, last name and salary. And let's save the updated employee information. And for delete, again, we're going to do the same thing. First, we want to check if the employee actually exists. So let's check that. So we actually have this method called exists by ID. If it doesn't exist, then throw a new exception where element not found. So actually, we could have probably done the same thing over here. So let's replace this with that part. Otherwise, if it exists, then delete the employee. I can't copy this part because actually I need the employee information, because I need to, when I'm storing the employee information, I need to get all of the name. I need to get the first name, the last name here. So this is a small bug here, and the salary before saving it to employee repository class in the database. Because when a person is passing in, he may not pass in the first name or the last name. He may just want to update the salary. But in order to store the entire employee information, we need all the information for the employee. So that's pretty much what I'm doing over here. Okay, so our employee service class is done. And now let's work on the payroll. So again, we're gonna follow the same style. We're gonna create the payroll interface. And let's implement the interface. And let's label this as service. Okay, so let's work on the interface methods for payroll service. Okay, so we're gonna implement the same methods, very similar to the employee service. So first one, we want to return list of all the payrolls. Next, we want to get payroll by ID and also by pay period. So this will return us a single payroll. And this will take in an employee ID and a pay period. Next, we want to get payroll by employee ID. So this will return us a list of payrolls for that specific employee. And finally, we want to add two more methods. We want to be able to add a payroll and also update the payroll. So over here, we're adding a payroll for a specific employee. And same thing, we want to be able to update a payroll for a specific employee as well. All right, so let's implement this interface. So again, the first thing we're going to do is we need to wire up our payroll repository. So this will be pretty easy. Again, same thing, find all. We're going to come back to this method shortly. So for this one, we want to get payroll for a specific employee. So first we need to check if the payroll, if the employee actually exists. So we're going to do something very similar we did before. So actually we need to wire up another repository employee because we're also interacting with the employee database as well, or the employee table, I should say. And for this one, I'm just going to copy this part. And we want to return the payroll for that specific employee. All right, so let's add the payroll. So for adding a payroll, so we're adding a payroll for a specific employee. And so in our table, if you go to our actually model for employee, we're adding the salary. So this is an hourly salary. So we need to calculate the gross pay. We need to calculate the gross pay and net pay. So to do that, we're gonna say, you know, we're gonna keep it simple for this. We're gonna say, you know what, our payroll gets generated every 2 weeks. So pretty much so a full-time employee works 80 hours. So for every 2 weeks, generate a payroll. So to do that, we're gonna first want to get the payroll. And we're gonna call the employee repository and check if the employee actually exists. So we're gonna first find the employee by ID. And if it's found, then map it. Then use a map function to get the employee information. And we want to calculate the gross pay and the net pay. So for gross pay, we're gonna say, just get the salary and multiply it by 80 hours. And for net pay, we're going to say, for net pay, use 80% of the gross pay salary. We have to pay our taxes to Uncle Sam and our insurance and retirement account. So we're going to keep it on the low rate. So we're going to say 80%. Next, we want to set the information for the employee. We want to set the gross pay and the net pay. And finally, we want to return the save information. Okay. And otherwise, you know what? If you weren't able to find the employee, then throw employee not found. Okay, our payroll is done, and we want to return the payroll. So now to update the payroll, it's going to be very similar to the way we did update for employee. So first, we need to actually get the payroll. So we're going to do find by ID. And then, so we can update the gross pay or the net pay. So we're going to give that capability to update those two information. So here we're checking if, if the gross pay is set or not. And same thing we're going to do for the net pay. Okay, and then save that information to the payroll table. So for get payroll by ID, we already created this very neat method for us that automatically runs a SQL query for us. So we're going to just call this method. And it should just return us that employee ID and by pay period. It's going to return that payroll. All right, so our logic for payroll service is done, and also for employee service. So before we end this video, let's push our code to the Git repository. So we're going to create a new branch. This will be for the feature branch for creating services. And let's push this branch. Okay, so our code's been merged. Okay, so we learned how to write services and why we split it by writing an interface and also a class that implements it. The reason for that is because we want to achieve abstraction and polymorphism. If in future, for example, if we were ever to create a new employee service and that has a different implementation than the current one, we can easily swap that without affecting the code that's actually calling it. And we'll actually see an example of this in the next video where we will write REST API or HTTP endpoint that will call this service.